The future of AI is not massive data centers. The future of AI is actually in the palm of your hands right now. Over the year, AI has pushed the boundaries of what's possible. But today, something extraordinary is happening. The NVIDIA Jetson Orin Nano Super is proving that small devices can now run models that were once thought impossible. And today, we are putting that to the test with DeepSeek R1 Distills. So, DeepSeek has gained a lot of popularity recently because it is one of the most powerful AI models available. But let's see, how does Jetson Orin Nano compare with Dell R730 server with dual NVIDIA P40 GPUs. So we're gonna run these DeepSeek R1 Distills on both these machines and we'll find out how do they compare. The results are surprising. So you'll have to watch all of the video and then you'll find out yourself how this tiny little device is so extraordinarily powerful in running these large language models. Let's see what we have. On one hand, we have the palm-sized supercomputer Jetson Orin Nano developer kit. And on the other hand, we have this massive Dell R730 server with two CPUs, each one of those having 12 cores, 24 threads with a combined 48 thread CPUs. And what I've done is I've assigned all this horsepower to a Ubuntu machine, and it also has two NVIDIA P40 graphics cards. So let's take a look. I'm gonna SSH into Jetson on one side, and I'll leave this over here and open JTop for us over here so you can see the statistics. And on the other side, I'll SSH into Ubuntu machine, which actually I already have, and I'll just do NVIDIA SMI over here. So you can see that on Jetson, we have just 8 gigs of RAM that is shared across the operating system and also with the graphics card. And on our Ubuntu machine, we have dedicated 24 times 2 48 gigs of VRAM dedicated to large language models. So these are the two systems that we'll be running our large language models on, specifically DeepSeek R1 Distills, and I'm going to show you the performance comparison between these two machines. If you're interested in seeing how I have set up these two servers, then I have a AI server setup guide on my GitHub. And you can take a look at that. There are Ubuntu server setup guides over here and the Jetson Orin Nano developer setup guide over here as well. So I'll post a couple of links in the video descriptions and you can take a look at how these two servers are actually set up, to the point that we have Ollama and Open Web UI installed on both Jetson Nano and on the Dell R730 server. Alright, before we take things further and we bring DeepSeek into life, we need to talk about what makes this model really special. So AI has evolved from simple text generation to deep reasoning and problem solving, and thinking models like DeepSeek R1, they are just next in the category and in the class. They do not just predict words, they analyze, they compute, and they assist in the complex tasks that regular text generation models fail at. And DeepSeek, specifically the R1 model, has been making waves. It's been outperforming OpenAI's O1 in key reasoning and coding benchmarks. And while being more resource efficient, it has also proven to be taken very less amount of compute power to get trained. And this is what is sending shockwaves across the industry over here. But there are another class of models that DeepSeek has released. So there is a DeepSeek V3 model that we have, there is a DeepSeek R1 reasoning model that we have, and then there is a distilled version of this model too, which is what most of us have been able to deploy on our local machines. What is a distilled model and what is the process of distillation? Let's talk about that. So if DeepSeek is actually beating O1 models, it cannot be a small model. And let me show you the Ollama's page over here. So DeepSeek R1 model is actually a 671 billion parameter model, which is no joke. So how does DeepSeek achieve such an incredible performance on consumer grade hardware or even on Dell R730 server, which has 48 gigs of VRAM? The answer lies in the technique called model distillation. So think of distillation like a large complex model like the actual R1 model, the 671 billion parameter model. It is a teacher model, and such a model is trained on a massive amount of data, a large amount of data. And once it has learned the information, then it attempts to transfer its knowledge to a smaller and more efficient model, which is what you are taking a look at over here. So there are 70 billion, 32, 14, 8, 7, and 1.5 billion parameter models. So everything else that is not 671 billion is actually the distilled model that you see over here. The real model is this 671 billion parameter model. So all these student models or the distilled version of the main model, they retain most of the teacher's reasoning capabilities, but they are way faster and smaller. And this is exactly what R1 distills are. They are the distilled version of the models that deliver top tier performance without the bulk 671 billion. But are they really as good and efficient as 671 billion parameter model? Maybe not, but they are good enough, and they are probably better than what their original versions were. And that is what we'll take a look at now. So there are certain models that we'll be able to deploy on our Jetson. For example, 1.5 billion, DeepSeek R1 Distill, 7 billion. And then there are some other models that we can deploy on our R730 server. So the 14 billion, 32 billion, and 70 billion parameter will go on our R730 server. Of course, we'll also try 1.5 and 7 billion on R730 just to see the performance over there too. But 671 billion, nope, we cannot deploy anywhere. So we'll be using the DeepSeek's API to do some testing over here, right? So, or actually their direct chat interface, which I've been, playing around with, just trying to get some information and knowledge out of it to see how much it knows about the technology where I'm an expert of. So I happen to be an expert in SAP Commerce, and I want to see how much this particular model knows about it, and it is impressive. So I gave it a instruction and command that, hey, I'm trying to create a documentation for SAP Commerce. Can you do it for me? And I'm going to feed this into an LLM. So it's just a hypothetical scenario, and it actually came up with very good documentation over here for me. And it's not only a simple documentation that it started creating, but it also started going in depth of each and every aspect of SAP Commerce. It is insane how amazing this model is at coding in a technology domain where not many people have expertise, let's just say that. So I was super impressed by the knowledge that this particular model, the 671 billion parameter model, has in niche skills also. So this was a very big eye opener for me that AI is getting to a stage where it can compete with humans in different areas where we may feel like we are comfortable being an expert in a domain, but nope, AI is over here to stay, and it is over here to compete with us. Let's see how DeepSeek performs on these two devices. So if you do Ollama run DeepSeek R1, you actually get the 7 billion parameter model and not the 671 billion parameter model. And these four models, 1.5, 7, 14, and 32, these are the Qwen 2.5 distills, whereas 8 and 70 billion are Llama distills. So this is the Jetson 3000, meaning the OpenWeb UI instance, which is hosted on Jetson server, right? And the second one, this is white in background, so it'll be easier to distinguish with the black background one, which is running on R730 server. So to get a fair comparison, let's also look at the hardware specs of these two, right? So the Dell R730 server, like I said, it features a dual Xeon E5 2680 V3 processor over here with 24 cores, 48 threads, running at 2.5 gigahertz and a massive 128 gigs of RAM over here with 48 gigs of VRAM coming from a dual P40 setup. This is a beast of a PC, of a server. On the other hand, we have Jetson Orin Nano Super, which is a compact edge AI device with 6 core ARM processor, 8 gigs of RAM, and an integrated GPU with 1024 CUDA cores. And this it does not compare anywhere close to the Dell R730 server. But we are going to run the two distills over here, and I'm going to show you the performance difference over here. So let's get right into it now. All right, let's just do the Roman Empire question on our Jetson over here. And let's just watch it think. And let's switch to Jetson's terminal. And you can see it's using 67%, which is decent. And I think this is about 25-30 tokens per second, if I'm not wrong. Let's take a look. 32 tokens per second. Impressive. Impressive. Okay. All right. Let's switch to our R730 server and ask the same question over here. So let's see the fun fact about Roman Empire. Let's just send it and let's take a look. Holy, whoa. Okay. All right. Now this is just showing off. All right, and we have 93 tokens per second, which is impressive, but it is only 3 times faster than our Jetson. Right? So imagine the compute difference between these two devices, and Jetson somehow just performs amazingly over here, right? I mean, of course, it is 3 times slower than R730, but it is still pretty good. Let's switch the model to the 7 billion parameter model, right? So you see this is the DeepSeek R1 7 billion parameter model, and we're gonna ask the same question again to this model over here. And let's just switch back to our JTOP. And once the model is loaded in the memory, which it is right about now, you can see that 6.4 gigabytes are loaded in the memory now. 7, that's nice. And I think this is where the model has started thinking. Okay, so it is working hard now, right? You can see the GPU is spiking, and then it is working hard, then it's spiking down, then spiking back up again. And I believe this is close to maybe 12 tokens, 10 to 12 tokens, if I'm not wrong. Let's see once it's done thinking and it is done writing the answer over here, we'll find out the tokens per second. All right, so we are at 6 tokens per second, 5.39 tokens per second. All right, which is okay. I mean, it is okay for a 7 billion parameter to be running on our Jetson, but let's do the same thing for our R730 server, right? So let's switch the model to the 7 billion parameter model, and let's just rerun and regenerate this. So it is gonna load the model over here, all right, and it is consuming 85% of power over here. Let's take a look. And really fast model. I would say that the performance is really good over here. Okay, so we got 3940 tokens per second, which is really good. So as compared to our Jetson, I think R730 has definitely outperformed our Jetson over here. Not just 3 times, but about 8 times over here, right? So we have 40 tokens over here as compared to about 5 to 6 tokens over here. So yeah, about 7 times of performance difference over here. You know what? Let's try this again. Let's try sending the same model, same question again on both the servers, and let's just see if there is any performance difference. So it's gonna think again over here. I think our R730 would be done very soon. So this looks like it is overthinking right now, but it is gonna finish. All right, it keeps on thinking and thinking. It's trying to come up with an argument that even though these are the facts that I can think of, are they actually fun facts or not? And I like how it is overthinking its own abilities in getting the fun facts out. But that's interesting to watch. And so is our Jetson. Okay, so we'll let them run. It is actually good that it is thinking more, because now the average token per second would be even better. So 37.6, which is again in that range, close to 3738 or close to 40 tokens. And let's see over here, if this one outputs the same amount of tokens, then this will take a while for it to output. Wow, yeah, another angle. See, so this is what I'm talking about. These thinking models, they are just so amazing. So we have asked them, tell us a random fun fact about Roman Empire, and they are just not letting go of this fun word. So they are making sure that they collect these facts, and they want to make sure that this is a fun fact. And if it is not, then they are gonna think more and try to come up and reason with more facts, which could potentially be fun facts over here, right? So I think it has started to summarize that, hey, okay, let's put it all together, which means it is coming to a conclusion. But then again, it went back again. Alternatively, maybe a more surprising fact that Romans had a system where they assigned specific tasks to women, such as laundry work, because they couldn't afford it. Okay, all right. So it is going into loops and trying to come up with even more fun facts, and it is doubting itself again. Okay, all right, so we'll let it finish so that we can see some tokens per second comparisons over here. But I think even though it is slow, I think it is decent enough that I would be able to bear with it. Because it is outputting tokens just as fast as I can read it right now. So it is perfectly 6 to 7 tokens, is a very decent reading speed for me. It's not putting stress on my eyes. Would I want it faster? Of course I would, but having this run in the palm of our hands is amazing. It's barely consuming any power as compared to Dell R730 servers, so that also is an amazing fact. Wow, look at that. Look at the thinking process over here. It is still thinking. It just keeps on going and going and going over here. Alright, so it has compiled quite a few fun facts, but it is still not giving up. It is still not giving up. Another thought. Okay, all right. It's digging in its memories, trying to get every single fact out. It appears before it will summarize the answer. Even though I think somewhere above it did say that it is putting things together. So combining these thoughts, it tried to put things together, but then it doubted itself and again started thinking again. Pretty amazing. Wow. Wow. So, I mean, this is really, really cool. So, even though in such a simple question, this looks like it is an overkill, but when it goes to reasoning for coding questions, it really does a very good job. So, it thinks about a situation, it comes up with a flow that normally the model wouldn't have thought about, and it tries to solve a problem from every angle, from every edge case that you can think of, which is what I really like. So I've been developing a agent called dangerously smart agent, and that agent first comes up with an architecture of a problem that needs to be solved. So this is the R1 model. The reasoning models are the best ones at writing an architecture, because an architect is a person that can think through the system from various angles. Hold on to that thought. Let's see how many tokens that we have. 5 tokens per second, 5.25, which is very good. So we are still at 7 times performance difference between R730 and Jetson over here, which is acceptable given that the powerhouse that our R730 is. All right, so let's do something different over here. So what I'm going to do next is give these models a context. I'm going to give them a cron job context over here, like how to write a cron job in SAP Commerce. So I'm going to upload the same documentation to both these files, and this documentation itself is generated by DeepSeek R1. So I am not taking any proprietary information from anywhere. I just went to DeepSeek R1, asked it to give me, the 671 billion parameter model. I asked it to just dump down whatever you know about SAP Commerce creation of a cron job, and it created a small documentation for me, which is big enough for me to insert into the 2000 context window of this particular model over here. So I'm gonna ask both these models the exact same question now, and then let's see how long they take to come up with an answer. The example that I have is write an end-to-end implementation right. So just write an end-to-end implementation of a cron job that sends an order to Kafka topic. And we'll do the same over here, and we'll send this to. So you can see how GPU is spiking over here on our Jetson. And at the same time, the CPU is, or the GPU is spiking on our P40s as well. So both these GPUs are working hard, and let's see what they come back with. So of course our R730 is the first to come back with an answer, and it is writing the answer for us. Okay, let's see if Jetson has started. No, not yet. Jetson is still working hard over here. Okay, let's go back to our 730. It has already started writing. Okay, let's see if the code is any good. So interesting that it is trying to get .mds in the code over here, which let me see, do we have like .md and stuff in the document? Let's see. Not really. So it's somehow because it found the reference as .md over here, it kind of inserted that anyway, so that is not very promising. It inserting all these attributes over here, it shouldn't do it. Replace and all that, I don't even know why and what is coming in over here. Okay, so let's see the performable interface. Nope, this is incorrect. It is probably just saying that this is the source that it has. It is messing up because some source has been provided to it. But at a very high level, it is kind of doing what it is supposed to do. So define job performable interface. No. Cron job model. So this is kind of okay. Create configuration items.xml. Okay, all right. So it has the right thought process over here, but I don't know why it is messing up with these search and equal to and all those attributes over here. It shouldn't do that. It's this replace and all that. I don't know why it is messing up over here, but it has the right thought overall. Like I can see that it has the right thought over here, how it is approaching to the problem. But nope, it is definitely not powerful. The 7 billion parameter model is not powerful enough to code, I will say that. And our Jetson has not even started yet. It is struggling. With that much amount of context, it is definitely struggling. Let's see how much context was there. So you can see prompt eval count. Prompt eval count is the context window over here, which was 1047 tokens that were passed in the context. And now, just now, it has started thinking. So when you provide more context to a model, it is more expensive for it to produce tokens to continue from there, right? So it does take way longer for that initial tokens getting out once you have more context provided to it. So that is why it was struggling. But let's see, we'll have this finish as well so that we can see how good of a job our Jetson is doing. Even though, you know, it doesn't matter whether the same model is running on Jetson or whether it is running on R730. They both should do almost similar kind of job at it. But something I do notice is that this version is not messing up with those search, right? So all these random equal tos and search, and I don't know where did it even get all this information from, but Jetson is not doing the same thing, which is good. It is also actually writing the cron job correctly over here. So this is also nice. I'm impressed. So the same 7 billion parameter model over here is doing a better job. All right, then it is asking to register the job in items.xml, which is good. And let's go further. I mean, it is painful to watch it type, but at the same time, it is better than our R730 server. You know what? We'll just regenerate this while the Jetson is writing code anyway over here, and we'll find out. Oh no, you don't write Chinese words in your code over here, DeepSeek. Okay, so let's see. Set up Kafka producer, localhost 9092, orders topic, okay. And offset based or custom partitioner. And it is saying public class order to Kafka job extends cron job. Okay. Topic. Okay, this is still working and our R730 is done already. All right, so it is done. It is still doing the same thing. It's still doing the same thing. Did we give the same context to both of them? 3.07, yes, and 3.07. The same context was given to both of them. You know what? Let's regenerate again over here because I think Jetson will take more time to produce its answer. Okay, so it did 5 tokens per second, which is okay. But you know, the code written by Jetson is better and more closer to a realistic code that SAP Commerce Developer will write as compared to the R730 over here. Let's see if R730 has caught up in its third turn. So it has attempted to create the producer first. Okay. Order to Kafka producer implements job performable. No, why did you do that? Okay. Okay, I mean, it's an interesting choice of the name over here. Let's see its reasoning, what it thinks. So first, I remember from the context provided that cron jobs are modeled using item types and can be triggered by cron expressions. Okay, that's good. Next, the user wants to send orders to Kafka. I think about the steps involved in sending data to Kafka. They probably need the Kafka producer class. Yeah, that's true. And then the main cron job will have a perform method. In this method, I'll check if the job is active. If not, activate it by setting the active attribute to true. No, I also need to handle exceptions. So it did its thinking, but it's okay. It thought through some of the things and it did some of its thinking over here. 31 tokens per second. All right. So this is the comparison, the performance comparison between these two models. The next comparisons that we will do cannot be done on Jetson anymore because those models won't fit in Jetson's RAM. So future comparisons with our 14, 32 and 70 billion parameters will only be able to do on R730 server. So let's switch our screen to our R730 only. And let's have our 8 billion. Let's do with this anyway. So let's have the 8 billion parameter load and do the same job over here. And it'll take a few seconds for 8 billion to load. But it's transferring from SSD to our VRAM. So it has loaded now. It is slightly bigger than the 7 billion. As you can see, 7 billion is loaded on this first P40. And the 8 billion is loaded over here right now. The 8 billion takes about 6 gigs of VRAM over here for us. Okay. Let's see how does the Ollama Distill do over here for us. Okay, so it is defining the cron job in items.xml. That is good. Implement the job logic. Okay, so order to Kafka job performable, perform. Okay, that is pretty good. That is pretty good. It gets the order ID from the cron job model. Not get order ID. Okay, not the best way to do it, but that is one way to do it. Well, that is no way to do it, but I mean, yeah, it cannot think of the business use case that I had in my mind, so I can totally see it. And then configure the cron job, system cron job, create cron job. No, you were supposed to use the Impex way of creating it, but okay, it did do better than the previous one, so that is fine. Let's take a look. 33 tokens per second, which is almost the same as the 7 billion parameter model over here. Let's switch 8 billion to 14 billion and let's see how this does over here for us. Let's regenerate, and I'm gonna be reading the thinking process from here on to see how these models are actually thinking before they are writing. So let's take a look at that. So this model is 15. It's still loading in the RAM right now. So 15 gigabytes, 15.8 gigabytes. Yep, 14 billion parameter model. Okay, I think this one already has the other Ollama model loaded too. So it is not 15. It is less than 15. 15 minus 5. I think it's close to 10 gigabytes over here. Okay, let's see. The speed is impressive. 14 billion parameter. It is not bad. So okay, I need to help the user write an end-to-end implementation of a cron job that sends orders to a Kafka topic using SAP Commerce. Okay. Looking at the context, there are examples of a cron job like product feed export and order archiving. Both use Java classes implementing job performable. Okay. Okay, so this is decent. This pretty decent reasoning and thinking process over here. Let's see this. Order Kafka export job performable, perform, list of order model, unshipped orders. Okay, order service, get order with status. This is really awesome. So this is awesome. I really like it. So this 14 billion parameter model actually did what I wanted it to do, even without me asking it to do. So this has started putting more thinking into it. So this is the first time that 1.5, 7, and 8 billion parameter models couldn't think to this level, which 14 billion was able to do. So let's see where it went. So then it is iterating over the list of these models and successfully sending the orders to Kafka over here. So where is it getting this Kafka producer from? So it is just assuming that the Kafka producer is in the context somehow, right? Because I don't see it instantiating the Kafka producer. Okay, all right. So it is better, like it has the right thought over here, but it can still do a little bit more, I would say. So also, it says to schedule this job, add this to the cron job scheduler, but it kind of put the same thing in this Java code, which is not right. So, I mean, it is a step in the right direction, but definitely it is not what I wanted to do. So I'll give it one more chance. I will have it regenerate over here and quick read through its thought process again to see if it can arrive to the right conclusion second time around. And yeah, you can see the old model got unloaded from the VRAM. So now only one model is loaded over here, which is the 10 gigabyte of model. So which is nice. All right, let's see. Let's give it one more chance is what I'm saying. Let's have it think through again. Oh, wow. Wow. So it is talking about it needs to do pagination to avoid OOM errors. So that is something to keep in mind. That is very nice. Okay. So 14 billion parameter model does seem like a smarter model over here because things that it is thinking about, normally the smaller models weren't even like thinking about it. So this is pretty cool. Wow, it is considering that idempotency is important, right? So if a job runs multiple times, it doesn't want to send the same order again. Pretty cool stuff over here. Okay, let's see. So define the cron job in items.xml. Yes, but buddy, you did it wrong over here. Okay. Send order to Kafka job, implements job executor. No. All right. No, you went on the wrong path over here. Okay, so it is. This is not a pass, definitely not a pass. But again, even though it is not a pass, it is doing a few things good. It is at least attempting to retrieve orders from an order service. I do like that. And it is attempting to do, you know, like a pagination over here, getting smaller number of orders and sending it because it was worried about OOM, which is pretty cool, which is very nice for a 14 billion parameter model to think about. So that was very nice. All right, let's see the tokens per second. 18 tokens per second, which is decent. 18 tokens per second. It was a nice speed that we saw. All right. Let's see if the stronger models can replace an SAP Commerce Developer or not. So I'm gonna go to an R132 billion parameter model. And now we will regenerate this. So that initial load is gonna take some time, pretty sure. So this 32 billion parameter model should take close to 20 gigabytes of VRAM. So I think it is going to push this model out from here. That's what I would assume. Oh, it's gonna keep it over here. Okay, so it's gonna keep this one over here and load the model on this GPU. All right. So let's wait for a few seconds for this model to get loaded, and then we can watch how the 32 billion parameter distill performs and can it replace an SAP Commerce Developer or not. All right, so our model is loaded now. It has started thinking now. Let's read its thinking process. So I need to help the user by writing an end-to-end implementation of a cron job in SAP Commerce that sends orders to Kafka topic. Let me think about how to approach this. First, looking at the context provided, there are examples of cron jobs like these, and these. User wants to send an order to Kafka topic. I don't see any existing code in the context that deals with Kafka. So can't cite anything over there. Okay, all right, that is good. That is what I want you to think, right? I want you to write the Kafka related code. Okay, so what it is saying is that they want to create a cron job class, implementing job performable, true, inject necessary services like order service, nice, and fetch orders and a custom Kafka producer service for sending them. Wow, okay, you thought through it. So in the perform method, I'll fetch all unprocessed orders. For each order, serialize it into JSON and send to Kafka. After sending, mark the orders as processed so they aren't sent again on the subsequent runs. Good job, model, good job. I need to include configuration steps too. The cron job model should be defined in items.xml, yes. I don't know if I should be happy or if I should be sad that an AI is really thinking like a human right now over here. Because yes, you are supposed to do this. If like a junior developer would come to me and he would ask me all these questions, and if he would lay down his reasoning that this is how he's going to code, I will be very happy. Yes, so since there is no context about Kafka integration, I can't provide citations. So I'll mention that the implementation uses common Kafka producer configuration without citing any sources. I should make sure the code example is clear and include necessary imports. And if they aren't in the context, the user might need to add these dependencies or services as part of their setup. Very, very nice job. At least you are thinking through the right steps over here. So DeepSeek, you are on the right track. Let's see how you write the code now. So based on the provided context, I don't see information related to Kafka integration or message brokers. However, I can provide a general implementation approach for a cron job that sends orders to Kafka topic using typical patterns and practices. Okay, that is what I want you to do. So you have created a order Kafka export job and implemented job performable. Very good. And you have auto-wired order service and Kafka producer service. Very, very, very good job. And now you are implementing the perform method over here, retrieving orders from the order service, and then for each order, you are first converting the order JSON, and then you are sending the order JSON to the Kafka topic. Holy crap. You did it, 32 billion parameter model. You did it. So order service dot mark orders as processed. Yeah, and then return new performable. And I did not even tell it the full use case. I just told it in a very simple sentence, right? That, hey, write an end-to-end implementation of a cron job that sends an order to Kafka topic. It is such a useless sentence. Like most of the thoughts were just in my mind that, hey, yeah, when you send an order to a Kafka topic, you have to mark it as processed also. Like all those things, I didn't give it. I did not give it these functional requirements. It itself came up with it because that makes the most logical sense over here. I'm impressed. 32 billion parameter model did a very good job over here. All right. And then it is configure the Kafka producer service. Okay, so it is creating a whole producer service over here and define the cron job in items.xml. Okay, this could be better, of course, but it attempted to do this. I can see how it did not know how to create a cron job in items.xml, but you know what, let's challenge it. Let's give it another context and let's show it how to create an item over here. I think I may have one of these attribute creation, I believe. Before I do that, let's just take a look. Item types. Yep, there is how you create an attribute. Okay. Look at this file and create the on job item dot xml appropriately, and let's see if it can do that. Because of course, if I'm not going to give it enough information on how to create an item type, it won't be able to do it. But it did do everything else quite decently. Like it was pretty good, spot on in coming up with the business use cases and scenarios and writing the code based on the code examples and samples provided over here. And what I really liked it was its reasoning, its thought process, what it wanted to do, and it accomplished in doing it with the limited amount of information that I had given to it. So that was pretty cool. All right, so our model has started thinking, and let's see. So up until now we had 1100 tokens given to it. I believe we may be at the limit over here, because this looks like a lot of tokens in this file. So let's see how much tokens it has. Let's also see the tokens per second. So 10 tokens per second for 32 billion parameter model, which is it's all right. I mean, 10 tokens per second is a decent speed. So let's see what it's thinking about now. So I'm trying to help somebody to set up a cron job in their project. Yep, you're right. And the user said, take a look at this file and create the cron job item.xml appropriately. But they didn't actually attach or describe the file. That's a bit confusing. Oh, so the context doesn't appear to this particular model as a file. Okay. In my previous response, I had created XML snippet for items XML with cron job model. Okay. So, okay, all right. So it wasn't able to correct it. So that's all right. Let's see how many tokens, and 613 tokens over here. So for whatever reason, it wasn't able to, even though it is referencing this file over here, I don't think it was able to actually extract any content from here, because it kind of outright rejected it completely. So let's see the tokens per second, 8 tokens per second, and which is all right. You know what? This is pretty decent. This is good. What I want to do next is go to the 70 billion parameter model and see how that performs. So let's switch the model to 70 billion parameter, and let's have it regenerate this particular response over here. And this is going to take some amount of time. So both the models got unloaded, and I think this will be close to 48 gigs, if not full 48 gigs, maybe close to 44, 45 gigs of VRAM occupied over here. So let's give it a few seconds, and then let's come back over here and see once the model starts thinking. The model has started loading over here, started working, and you can see how 22 and 22, so 44, 45 gigabytes of model is loaded into the memory. So I know that 70 billion parameter is Llama 3.3 Distill, right, which is a good model in itself. But this is going to be huge. You can see already it is working really hard over here, loading the models and attempting to start processing with this amount of context already in its context length. So let's give it a few more seconds, and then, oh, it has already started thinking for us. Okay, let's see. So this is a decent speed. I think it's close to 5 tokens per second if I'm not wrong. So appears that the 70 billion parameter model on R730 is outputting tokens as 7 billion parameter models on our Jetson Nano over here. All right, so let's see how the 70 billion parameter model does. So this is supposed to be the best distill out there. So let's see how it does. So let's read. So user is asking for an end-to-end implementation guide on creating cron job in SAP Commerce that sends orders to Kafka topic. I remember from the context provided that there are several steps involved in creating a cron job. Let me try to break this down. First, I think they need to define a custom cron job. From what I saw earlier, this involves modifying items.xml by extending the cron job type. So I should outline how to create an order to Kafka cron job type here, including any necessary attributes like a reference to a Kafka configuration or topics. Okay. Next, implement the job class is crucial. The context provided an example of product feed job that implements a job performable. So for this task, I'll need to create an order to Kafka job class. Okay, nice thinking. The perform method should fetch orders, perhaps using a service like order service, process them, send them to Kafka, and handle success or failure results. I also recall the importance of cron expressions, so I should explain how to configure the cron job with the correct schedule in back office. Maybe suggest a specific interval based on common practices. Okay, so it is gonna suggest that too. That's nice. Security is important, so configuring JAS and Zookeeper properties would be necessary. Good job. Okay, so it is going beyond SAP Commerce and also thinking from Kafka point of view. So testing each aspect is essential to ensure everything is working smoothly. The user should verify that the cron job runs as scheduled, fetches orders correctly and successfully, and sends them to Kafka topic without errors. All right. Lastly, monitoring the logs after deployment will provide insights into how the cron job is performing and help catch any issues. Putting it all together, I'll structure the response step by step, starting from items, then the job class, then the cron configuration, dependencies, Kafka setup, security, testing, and monitoring. Okay, if you can actually do that, DeepSeek R1 70 billion parameter, if you can do every single step the way you are saying it, then you probably are at a point of replacing one of us. Let's see. So define the cron job in items.xml. Item type, code, auto. Okay, all right. So it is starting to understand how to write an items.xml correctly. Okay, so I mean, even though it is not the perfect implementation yet, but it is getting close to it. So I'm pretty sure if I had provided it enough samples and examples of how to create the cron job accurately, it would have come to the right conclusion. So 70 billion parameter model is a strong model over here. Wow. Okay, and implement the job class. Let's see this. So order to Kafka job extends abstract job. Okay. So it just did not do exactly. Let me look at the context over here. Was the context having two different implementations? Because it was supposed to do the job performable, but it did not do that. So for some reason, it chose to not use the sample code that was provided over here. Yep, so the job performable is what it was supposed to do. but for some reason it deviated from there and it used its own method over here with an abstract job. Okay, I mean, I won't give it a pass because of this, but it at least, you know, thought through some of the things. Okay, order to Kafka job. So it is creating actually the whole properties and then creating a producer with these properties over here. All right. Then public void execute, and then it is fetching a list of orders from order service, which is good. It is sending orders, but then it is not doing what the 14 billion parameter model was doing, right? It had a step to actually mark the sent orders as processed so they don't get picked up by the next run of the cron job. So this missed it while sending to the Kafka producer, to the Kafka topic using a producer. It is sending it to the producer, right? But it is not actually marking it as done, which is not good. Okay, so it is yeah, this is something that no other model did. It is showing us which dependencies we should use in our pom.xml file, right? I mean, in SAP Commerce we have it in a different way, but all right, that's all right. And configure Kafka producer. Yeah, this is good. Implement order serialization. So nice. Okay, so it is gonna write a serializer also for us so that it is easier for us to send that order. Good. And monitor and log. So nah, still cannot replace one of us. Unfortunately, a distill model cannot replace one of us. Let's try to rerun this again and let's see if it is able to produce a better answer over here. I really want it to be good. I'm gonna give it one more chance and see if it can produce a good answer. The model is still working and it is loading and fitting things into its context over here, and we'll just wait for a few more seconds so that we can see how long it'll take for it to generate the response this time. Okay, so the model has started thinking now, which is nice. And let's see. I need to write an end-to-end implementation for a cron job that sends orders to Kafka topic. And let me start by understanding the requirements. I should outline the main steps involved in such an implementation. You are right, that is what we are looking for. So I'll need to create a new job performable class. There you go. The job should fetch orders, process them, send them to Kafka, handle errors, log events, clean up, and return a result. Let's see how you are going to handle the cleanup process over here. So setting up dependencies is crucial. That is good. And Spring Kafka if needed, since the context didn't specify Kafka setup, but it is necessary for integration. I think I should have let it know that assume that Kafka integration exists, but that's all right, let it think. Next, configuring the Kafka producer is important. The user will need to set properties like bootstrap server and all that. Implementing the cron job involves writing a class that uses the Kafka template to send messages. Oh, so it's going the Spring route using the Kafka template over here. Okay. I also need to explain how to schedule the job using the cron expressions in SAP Commerce Cloud. This means creating an XML file with necessary configuration pointing to the new cron job class. Okay. Security considerations, finally mentioning that it is important for maintaining the setup. Tools like Prometheus and Grafana can help track metrics, while logging helps debug issues. I need to make sure each section is clear and provides enough details so the user can follow along without the prior knowledge of Kafka integration with SAP Commerce. Okay, all right. That is again giving us POM XML, all the build Gradle, okay. And we have our XML file over here. Let's see, configure Kafka producer. Create a configuration class to set up Kafka producer. Okay, so it is separating out configuration of Kafka on one side. That's all right. Let's see. I'm more interested in the SAP Commerce side of the code because I want to believe that 70 billion model parameter will do a good job at Kafka as it is, because Kafka is a known open source technology, and it will have less harder time writing code around Kafka. So let's see. It is still trying to configure things around Kafka over here, which is okay. So step 1 was set up dependencies, step 2 was configure Kafka producer, step 3 is create the cron job class. So it is not doing a good job at it, even though it said that it is gonna use the job performable. It did not do that. So this version of the code went deeper into Kafka piece of it than SAP Commerce piece of it, and it is messing up now. I really wanted to do a better job. I mean, it has some right thoughts over here, and like, given the code it has written plus some expertise from a commerce developer can definitely fix this, but it's still not writing as good of a code that I would have wanted it to. But again, nothing beats the 670. The real R1 model is insane. So the real R1 model definitely does a very good job. I think another thing that we can do is choose the 32 billion parameter model, increase the context length of that as 32K instead of 2K, and just dump a ton of documentation in its context and see how it behaves. And maybe this is something that I can do next. This video has already gone too long, but maybe I can make a follow-up video and see the reasoning process if I dump maybe like 20 to 25K context length and leave aside like 6 to 7K for it to have back and forth communication with the user in the subsequent turns. All right, so what I would say is that this was not as good of a job that it has done this time around. So I would not give this a pass. And I think it is still safe to say that the distill versions, at least the Q4 quantized version of these distills, they aren't as good yet. So they did a good job. I think my favorite one was the 32 billion parameter model, because that is the one for which I can increase the context length to 32K, and I can safely have enough VRAM in my R730 server. So the speed to the VRAM capability and to the quality of the answers that were produced by the Quen model was really, really good. I will still stick by it. 32 billion parameter model, 32K context length is the way to go if you have 48 gigs of VRAM over here. All right, so once this one is finished, let's see. 4.39 tokens per second. That was painful. I mean, 5 tokens per second, it is okay. It is okay to read. Once it is producing text, it is okay. Once you are asking it to write a joke, it is okay. But when you wait for it to finish a piece of code and there is nothing to read over there while it is finishing a piece of code, you are just sitting over there idle and watching it do it. So 5 tokens per second do get painful to watch. All right, well, that is all that I had on my list today. It is the fact that we can run AI models now on these devices, right? So on the edge device, we can run 1.5 billion parameter model and 7 billion parameter model. And on the servers like R730 with two P40 graphics cards, we can have the full 70 billion parameter model Q4 quantized, of course, run. And this is really amazing. And I hope you enjoyed watching, the differences between the performance of these two mini servers, the supercomputer in the hand, and an actual server. And if you did, if you enjoyed this deep dive into AI, into this Jetson Orin Nano Super and the Dell R730 server, don't forget to like, subscribe, and stay tuned for some more cutting edge AI experiments that I'm gonna do next. See you guys in the next video, and thank you all for watching this.